Hello everyone, I am Professor Amit Thakur. Today our topic is operations in linear array with implementation in C. Also we are going to cover the following topics like array initialization, accessing elements into the array, insertion elements into the array, deletion elements from the array, searching elements, and last updating the elements into the array. After this session, the learning objectives like discuss the linear array initialization, explain the concepts of accessing elements in linear array, explain the concepts of elements insertion, deletion, searching, updating in linear array. What is linear array in C? First of all, we should know what is the definition of linear array. A linear array is a collection of elements of the same data type arranged in a sequential manner. Each element in the array can be accessed using its index, which starts from 0 for the first element and goes up to the size of the array -1 for the last element. So, array always starts from 0. What are the advantages and disadvantages of using array in C? There are some advantages, also there are some disadvantages of using array. So, first of all we will start with the advantages of array. Array in C have own advantages and disadvantages which should be considered based on the specific use case and requirements. Here a list of some advantages and disadvantages of using array in C. First of all, now we will discuss about the advantages. The first advantage is random access. Elements in array can be accessed directly using their index. This provides a constant time access, making it efficient for retrieving elements by their position. The next advantage is memory efficient. Array allocates contiguous memory allocation, which can lead to better memory usage and cache locality, resulting a faster access time. The next advantage of using array is simplicity. Arrays are straightforward and simple to use. They provide a basic data structure for storing multiple elements of the same type. The fourth advantage, now we can talk about the compile time allocation. The arrays are allocated to at compile time, which can be advantageous in cases where memory allocation at runtime is not desired or feasible. The fifth advantage about array is predictable performance. Array operations usually have predictable and constant time complexity, making them suitable for certain algorithmic implementations. Now, we are going to talk about the disadvantage of using array. What is the first disadvantage? This is the first advantage. Disadvantage is fixed size. Arrays in C have fixed size, which means you need to know the maximum number of elements you will store in advance. Dynamic resizing requirements manual memory management. So, this is the first disadvantage and bigger disadvantage of array. Second disadvantage is memory wastage. If you allocate a large array, but only use a small portion of it, memory can be wasted. So, a user should know what is the exact memory they are going to use. So, this is the second disadvantage of using array. The third disadvantage is insertion and deletion overhead. Inserting or deleting elements in the middle of the array requires shifting elements. So, this resulting in potentially expensive operations, especially for the large array. The next disadvantage is lack bounds of checking. C arrays do not have built-in bounds checking. So, which can be lead to buffer overflow and other memory related errors if not carefully managed. So, this is a bigger we can say this is a bigger disadvantage in array. The next disadvantage is inflexible resizing. Resizing an array in C requires manual memory reallocation using functions like realloc, which can be error prone and may lead to the memory fragmentation. This is there can be two in fragmentation like sorry फिर से बोलूँगा slide. Now, we will talk about the fourth disadvantage, lack of bounds checking. C array do not have built in bounds checking, which can lead to buffer overflows and other memory related errors if not carefully managed. The fifth disadvantage is inflexible resizing. Resizing an array in C requires manual memory reallocation using functions like realloc. Realloc basically it is a function which is defined inside alloc.h header file, which can be error prone and may lead to the memory fragmentation. There are two types of fragmentation: internal fragmentation, external fragmentation in operating system in case of memory. The next disadvantage is not suitable for dynamic data. Array is not suitable for the dynamic this kind of data, for handling data that can changes dynamically in size, as resizing can be complex and inefficient. Next is pass by value. When passing a array to the function, it is passed by value, which means the functions works with a copy of array. This can lead to unexpected behavior if not understood properly. In case, one thing I want to add in this, if we pass this array to the function as a pass by value, means there will be more memory requirement. So, this is a disadvantage of using array. In summary, array in C are fundamental and efficient data structure for storing multiple elements of same type. They are suitable for scenarios where the size is known in advance and random access is a primary requirement. However, their fixed size and lack of dynamic resizing capability can be limitation in certain applications. For more flexible memory management and dynamic resizing or sizing, the other data structures like linked list, dynamic arrays or data structures provided by C++ standard template library, that is STL, can be considered. A linear array in the context of computer science and mathematics refers to the data structure or arrangement of elements in a sequential order. It may also commonly known as a one dimensional array. When we talk about the types of array, there are number of type arrays, like one dimensional array, two dimensional array, multi-dimensional array. Now, here I am going to talk about only one dimensional array. An array is a fundamental concept in programming and it is used to store a collection of elements of same data type under a single variable name. Linear arrays are used extensively in programming to store and manipulate data in various algorithms and applications. They offer a simple and straightforward way to manage a collection of values in the memory. So, the following operation we are going to cover in this session, like array initialization, how we can initialize the array, accessing elements, like how can we access the elements from the array, what are the way by which we can access the elements, insertion of elements into the array, how we can insert the data into the array, deletion of elements from the array, searching the elements into the array, and last updating the elements. Now, first we are going to talk about this array initialization. Now, array initialization is the process of setting the initial value for the elements in the array. When you create an array, the memory is allocated to hold a fixed number of elements, and during initialization you assign values to those elements. In many programming languages, array can be initialized at the time of declaration or afterwards, depending upon the context and the language features. So, this is one demo example of how we can initialize the array elements. First of all, we can see I have used two header files, stdio.h and kunu.h. Now, I have taken one macro app max underscore size, the size is 100 I have given already. I have written void main function. Inside this void main function, I have taken one array elements like arr, and I have given the size of arrays max underscore size, that is 100. Now, when we talk about how we can take the value of the size of the array, I have taken one variable and this variable's name is size. Now, we can print simple a message, we can like enter the elements to the array, and we have one loop, that loop starts from 0 up to the size -1 and I plus plus. I have initialized this array with 0 and I have taken the increment plus plus, and this inside this loop I have scanf some elements and I have stored those elements into the address of arr, and now I have simply write a message to print this element with the help of this array, printing the elements under the array loop. Accessing the elements. Accessing elements involves retrieving the values stored at a specific index within the array. The array index represents the position of elements within the array, and it typically starts from 0 and most programming language. Remember, the array indices typically starts from 0 and go up to array length -1. When array length represents the total number of elements in the array, Be cautious of accessing indices that are out of bounds, as this can lead to the runtime errors or unexpected behavior. Always ensures that the index you are using is within the valid range of the array. This is the example how we can access the elements from the array. I already taken this array's max underscore size as a macro, and the size of macro is 100. Inside main function I have declared some variables, array variables like ARR, and I have taken the size of ARR is max underscore size, that is 100. I have taken two more variables, size and index. First of all, I want to print a message like enter the size of the array, and I have taken this value, whatever value will be entered by the user, into the variable name size. Enter the elements of the array inside the loop. I have used one loop, for loop. It starts from 0 up to size minus 1 and I plus plus, that is a increment. In this inside this loop, I have used one function scanf to take the input from the user and stored in the array. Now after that, I have used one printf method to display a message like enter the index of elements you want to access. Here I am just asking from the user to index writing the index number, so that we can access the data or element from the array. Here I have taken the variable name index. Under this index variable, I have taken values from the user of which index you want to search. If I have taken this if control statement, this control statement says the condition like index is greater than or equals to 0 and index less than of size minus 1. So, in this inside this if block, I have simply printed a message like elements at index %d. The here %d is a format specifier to print the any decimal value, and I am printing here the index number. After index number, I am simply printing the ARR of index. So, it says this value is at particular location. If elements is not present in the array, we will go to the else part and it will simply print invalid index, please enter index between 0 to up to the size minus 1. Now, we will talk about the insertion element into the array. Here there are some step algorithms involves in this insertion of elements into the array. The first step we are going to take like initialize array, and I have taken one and I have used one array function, this function, and the function I have provided two parameters like array comma size. This will initialize the array and sets its size. The second thing, the second function we can take is insert element. In the insert element, I have taken the 4 parameters like array, what is the array name, second is size of array, third is index number, and last is value. So, I have taken these 4 parameters from the user. This will check if the index is valid and if the size is within the maximum limit. Second, it will shift the element to create space for new value moving from the end to the specified index. Third, it inserts the new values at the specified index and it will increment the size of array. So, these 4 things will be done by this function. You can use this algorithm as a guide to implement array insertion in your C program. Keep in mind that this is a simplified algorithm for educational purpose. In a real world scenario, you might consider handling memory allocation and deallocation more carefully as well as ensuring proper error handling. I have simply written one program. In this program, as I already taken max underscore size as 100, I have taken the same macro with the size of 100. Inside the main function, I have taken some variables like array, and thus I have given the size of arrays max underscore size. Another variable is size, index and value. These 3 variables I have taken. After this, I have simply printed a message like enter the size of array, and I have taken this variable into variable of the size variable. After that, I have just printing the message like enter the elements of the array, and after this statements, I have taken one loop because I have taken the multiple elements. So, I am writing a loop. Inside this loop, I have taken the values from the user using the scanf function. After that, a message is given with the help of printf function like enter the index where you want to insert the element. I am asking this from the user where you want to insert this element, and I am asking the index number. After providing the index number by the user, another message I am writing here, please enter the value to be inserted. Now, I am asking the value. First, I have asked the index number. After the index number, I have asked this value. I have taken one this control statements, and thus the condition would be like index less than of 0 or index is greater than of size. So, this is simple condition I have put over here. Inside this put I am just writing invalid index, please enter valid index number from 0 to length minus 1 of the array. If the index is less than 0 or greater than size, so it will show invalid this index number. Other else part we can write the shift element to the right to make this spaces. For this purpose I have used one loop, and the loop starts from I equals to size minus 1 and I is greater than or equals to index and I minus. I am here the decrementing this value of I. Inside this loop I have written AR of this array name I plus 1 equals to ARR of I. So, I am putting the value of ARI into the ARR of I plus 1, the next element. I am basically shifting the indices. After this I am just putting the value of whatever I have to insert into the ARR of index number. After this I have to increment the size plus by this operation I can increment the size to the next value, and the last I am just printing the element inserted successfully at the proper location. So, this way you can insert your element at proper indices. Now, we will talk about deletion of array elements from the array. Here is a breakdown of each step in algorithm. As I have taken initialize array function earlier, here I am also going to take this function like initialize array. This will initialize the array with the help of their size. So, I am taking two parameters in this function array comma size. This will initialize array and its size, it sets its size. Second function I am going to take delete element with I am taking the three parameters like array, size and index. Simply it will check if the index is valid or not. Second thing, it shifts the element to remove the deleted value, moving from the specified index to the end of the array, and it will it will decrement the size of the array, because if I am deleting the element from the array, obviously the size of the array will be reduced. You can use this algorithm as a guide to implement array deletion in your C program. Keep in mind that this is a simplified algorithm for educational purpose. In a real world scenario, you might consider handling memory allocation and deallocation more carefully, as well as ensuring proper error handling. Here I am writing this code, this sample code for deleting elements from your array. I am taken one header file like stdio.h header file. This header file includes with my source code. After this I have used one macro, again the max underscore size, and the size I have taken is 100. This size may vary according to your requirement. You can change the size of this macro. Under this void main function I have taken one variable name like int ARR, and under the size of array is max underscore size, that is 100. After that I have taken two more variables like size comma index, then both have type of integer. Now I am printing a message for the user like enter the size of the array. With the help of scanf function I am taking the size of the array from the user. The user will simply enter the size and it will store in the memory a variable of size. After this I have written a message like enter the elements of the array. For the array input, again I have to take one loop so that I can take the value for the array. Here I have to run a loop like for I equals to 0, I less than size and I plus plus. Inside this loop I have simply used one scanf function, and scanf function is saying like whatever data will be inserted into the address of array. Next I have simply written a message enter the index of the element you want to delete. Here I am asking from the user the index number of array which you want to delete from the array. Here I am simply writing a control statements. In this control statement I have written as condition like index less than 0 or index greater than or equals to size. This will say invalid index, please ensure the index between the 0 and the size minus 1, because if you do not enter the proper index of the array, it will show an error message. If you enter proper index number, it will go to the else part. This will do nothing like shift elements to the left to the override the element to delete it. Like I have used one loop, for loop, and I started I equals to index, I less than of size and size minus 1 and I plus plus. So, this will simply run a loop from starting from index up to the size minus 1, and now what I have done, I have simply ARR of I plus 1, the next element would be assigned to the previous element ARR of I, and after this I am just reducing the size like size minus minus. So, this will decrease the size of the array. At the last I am printing a message like elements deleted successfully. This is how we can delete an element from the array. Now, we will talk about searching element into the array. Here are some steps which are involved to search the elements into the array. The first function I am going to use initialize array. In this function I am going to take two parameters array comma size. This will initialize the array and sets its size as I told you in previous slides. The next element, the next function would be like search element, and the search element I am taking three parameters array, size comma target, three parameters. This will simply iterates through the array comparing each element with the target element. If a match is found, then returns the index of the target element. If the element is not present into the array, it will return -1 as a not found indicator. You can use this algorithm as to guide the implement array searching array element searching in your C program. This is a simple, this is educational purpose example I am taking over here. In real life world scenario, you might consider the optimizing the search process using different searching algorithms. There are number of searching algorithms available for this for array elements like binary search, linear search and different searching element. So, if you use binary search, the main thing you should keep in mind that the array should be sorted and handling the various data types. This code says how can we the value can be searched through the array. Here I have taken one header file stdio.h. This header file will be included in my source code. Again I am taking the max underscore size as a macro, and the size of this macro is 100. Inside this main function I am taking this ARR as a array name, and the size of this array is max underscore size. I have taken more two variables like size and value. This size will be I will ask from the user to enter the size with the help of this print function, and scanf function is responsible to store that entered size by the user to the size variable. After this I have written one statement, enter the elements of the array. As I told you, if I am taking the multiple elements and I am taking the similar kind of elements into my array. So, I am writing a loop. Inside this loop I have used one scanf function. Scanf function written like %d comma address of ARR of I. This is nothing but the whatever value will be inserted will be checked whether it is a decimal number or not by the format specifier. If it is a decimal number, then it will store each element at the address of I. Here you can see the I is being incremented every time. So, next element will be inserted into the next address of the array. After I have written one statement like enter the value to be searched. Now, I am asking from the user, so please enter the value you want to search into the array, and I have taken two more variables, found equals to 0 and index equals to -1. So, I have initialized this variable by intentionally, how we will see later in this code. I have taken one loop I equals to 0, I less than size and I plus plus. First of all, I will try to match the value from the array element like ARR of I. The first element will be matched with the value what we have inserted, what I have taken from the user. If match is found, I have simply write a found equals to 1, index equals to 1 and break, because if I found the value I do not need to go ahead in my code. So, simply writing a break. Here break is a statement which takes the control outside this block. If found, after this I have written one else if else block. In if else block I have written if found. If found the value is found, I am simply printing the index of that found value, else I am simply writing a message like value is not present in the array. This is how we can search the element into the array. Now, updating the elements into the array, how we can update the elements which are present into the array. Like the first function I am going to take is initialize array, as I already taken in previous slides, and this two and this function I am going to take two variables like array comma size. So, this is a by parameters function. The first parameter is array and the second parameter is size, because these two parameters are more necessary to initialize the array and the size of the array. Second function is update elements. In this update elements I am taking the four parameters. The first parameter is array, second parameter is size, third parameter is index, and last parameter is new value, which I am going to update with the previous elements. So, this will check if the index is valid and updates the element if the specified index with the new value. This is how we can replace the updated value with the old value. You can use this algorithm to guide to implement array elements updating your C program. You should keep in your mind that this is for educational purpose only examination. In real world, you might have considered different handling error cases such as out of bound indices, ensuring proper memory management, because sometimes we feel a user can enter सर इसको फिर से बोलूँगा You can use this algorithm as a guide to implement array elements updating in your C program. Keep in mind that this is a simplified algorithm for educational purposes. In real world scenario, you might consider handling error cases such as out of bound indices and ensuring proper memory management. This might arise the error when you enter the indices number which are out of the bound. Now, we can see this is a simple sample code how you can updating the elements of the array. As I have used earlier, like this header file std.h, here I am taking this header file also with after this header file I am used one max underscore size, the size is 100, and this is a simple macro. You can please remember this macro size can be changed according your requirements. It is not necessary it can be fixed for 100 only. It may vary depending upon your requirements. Under this main function, I have taken one array variable ARR, and the size of array I have taken max underscore size, that is 100. After this, I have initialized 3 variables size, indices and value. So, 3 values may be considered here. After this, I have written a statement enter the size of the array from the user. So, array user the user will be enter the size of the array, and this scanf function is responsible to enter this size of the array into this size variable with the help of %d format specifier. After this, enter the elements of the array. I am writing this message, and for entering the elements into the array, I have used one loop. Under this loop, I have used one scanf function, that is scanf %d address of ARR of I. This array will start from 0 up to the size -1, and I have taken one I plus plus increment to increment your loop. This is a simple for loop I am using to enter the element into the array. After this, I can write a simple message like enter the index of the elements you want to update, because this is necessary part. You want to you ask the user to enter the updating elements of the index number of that you want to update. So, I am writing a scanf function %d and index address of index. I am putting a simple condition inside if block. First of all, you should see means the index is proper index or not. So, I can take a condition like index greater than or equals to 0 and index less than or equal size. So, this is a proper index I can take, because the index starts from 0 to size -1. If proper index enters, I can again printing a message enter the new value which you want to update. So, again I am taking a scanf function. For scanf function, writing the %d comma address of value. Here ampersand sign denotes the address of value which you have entered, and this will store at the address of value. After this value will be assigned to the ARR of index. This index number will be had been already inserted by the user. So, this value will be updated. Printf function says element updated successfully. This is statement, simple statement I have written over here. If nothing goes well, it will go to the else block, and I am writing this message invalid index, please enter index between 0 to size -1. It is important to consider specific requirements of your program and the characteristics of the array data structure when choosing which array operation to use. Depending upon the programming language and use case, certain operation might be more efficient or practical than the others. When choosing a data structure, consider factors such as the following things you should know before choosing your data structure carefully. The first thing you should know what is the expected size and growth of the data, because this is the most important part of choosing your data structure. You should know the size of your data structure and the growth of the data, how much your data can be extend. Second most important part is type of operation. What kind of operation you are going to perform with your data structure, like insertion, deletion, lookups. So, different kind of operation you can perform with your data structure, but you should know in advance what are operation going to perform with your data structure. The third most important part of choosing data structure is access patterns. Means that number of access patterns you can use for a data structure like random or sequential. Random means suppose there are number of elements present in your array or some the different data structure, you have to use this random selection or sequential selection. So, first of all you should know how I am going to access my data. The next important part is memory efficient. Your data structure should be memory efficient, because as you know the memories are limited. So, we should consider a data structure which is more memory efficient. Next important part is trade offs between the time complexity and the memory usage. As you know, the time is more crucial part, and the memory is more crucial for the data structure. So, you should know what are the trade-offs of between the complexity and the memory usage. The next requirement is specific requirements of your program or algorithm. So, these are the some factors you should know before choosing your data structure. Selecting the appropriate data structure is crucial for designing efficient and effective algorithms and programs. Each data structure has its own strength and weaknesses, and the choice depends upon the problem you are solving and the performance characteristics you need. So, with this I am conclude my session. So, thank you so much.